So for this question, now the maximum displacement of the diving board occurs at t equal to 0, right? So we're gonna make this. So let me just change this. So the maximum displacement. So I'm gonna write here max displacement is t equal to 0. So the function, the model of this function is going to be look like this. So it's going to be y equal to k times e to the negative ct times cosine of wt. So this is for, you use this function to model this type of problem. So because this is like a model for the motion of diving board, because the graph of y equal to cosine t has y-intercept like other than 0, right? So then the maximum displacement when diving board is at 20.3 centimeter above its resting position, right? That's given to us. So the end of diving board is 20.3 centimeter above its resting position. So that's going to be the maximum displacement. Therefore, the total displacement K is really just going to be the maximum displacement minus the minimum displacement. So therefore, I'm just going to write the total displacement for the K. So basically, the K here is going to be 20.3. And now we need to find a constant C, and that's really just this. So that's called a dumping constant for C, or for the diving board. So that will just be this. So it's just this dumping constant. So that C equals 0.901. Okay, now since after 2 seconds, the board has moved down and up 12 times, then it will have moved down and up 6 times after a second, right? That's the rate of moving up and down. So then for every 1 second, it's going to move up and down 6 times. So therefore, I will just do this. I will just do this. I'm going to try to find this W, right? So this W, so divided by 2 pi is going to equal 6. So therefore, the W will equal to 12. Then our function is going to be this. So the y equal to k is 20.3 e to the negative 0.901. That's our constant. So times t, then times cosine of 12 t. So that's our model, because that's what the question is asking, right? Right, the function, this is a function of t. That's part A. Now for this part, and then it says determine the amount of time of the t, right, that it takes diving board to be dumped, so that y is between 0.5 and 5. So basically, you want the y to be between 0.5 and 5. So how long does it take that? Okay, so this is really just going to be about, okay, so if y is between 0.5 and 0.5, so then it will really be about, so t is about 0.09 seconds. Okay, so if you plug this number into the t right here, and you will see that the y value is always going to be captured between these two numbers, because cosine of 12t will always be really smaller than 1, right? So all you need to do is make sure that this is between negative 0.5 and 5. So if you graph it, if you just put it in your calculator and graph it, then you really see that, about 4.09 seconds, then the value of y is really captured between 0.5 and 5. So that's basically it.